Hi everyone. I hope your week is going well and that you're getting through the material fine. Let me know if you have any questions. This is 1.3 part 2. So for Math 99, this will be your last one for radicals. We'll get more into them later, but you'll be learning some concepts that will apply later on. For Math 140, you'll need to do part 3, which will be coming up shortly. So again, you can just copy things down as I write them, print out the PDF, or use the accessible version in Canvas. So for here, we have a property nth root of a to the m. So sometimes writing it in a different format helps us to simplify things, and also when we're solving later, when we have to use logs and things in your pre-calc, you're going to need this method. So nth root of a to the m could be written as a to the mn. So this fraction here is an exponent. That could be split apart using our exponent laws. So we have on this third one over, we have a to the 1 over n to the m is also an equivalent way to say that. Likewise, we could do the numerator first. We could do a to the m to the 1 over n. So those are all equivalent things to say. So that's a property that you'll want to memorize or jot on an index card. For example, if we had the third root of x to the 7th, we could write that as x equals 7/3, or we could write that as x to the 1/3 to the 7th, or we could write that as x to the 7th to the 1/3 power. So we're going to use that property to simplify some examples. So I'm going to do an example, and then there's a problem for you to try directly after. So here's example 1, 81 to the 1/4 power. So we can figure that out by putting 81 into its prime factorization. So we could manipulate that 3 to the 4th. And this is an important skill that you use later in pre-calc. So we can write that as 3 to the 4th would be equal to 81, and that then is raised to the 1/4 power. And using our exponent laws, we multiply when we have power to a power. So we would have 3 to the 4 over 1, basically, times 1/4, and that exponent then reduces to just be 1. So we would have 3 as our final answer on that one. So I encourage you to pause the video and then do problem 1 right now, or you could go back and do all the problems after watching all the examples. Okay, so I'm just going to quickly write out the steps for problem 1. Sorry about that. So we have 8 to the 2/3, so we would, hopefully you've tried this on your own, but that would be equivalent to 8 to the 1/3 squared. So we're just kind of working in reverse, splitting that fraction up. And then we can figure out 8 to the 1/3 would be equivalent to 2, because it's the same thing as the cube root of 8. 2 times 2 times 2 would give us 8. And then we write our squared. So we have 2 squared, and that calculates out to 4. If you did it the other way around and did 8 squared to the 1/3, that would become the same answer. So 8 to the 2/3 equals 4. Example 2. we have 125 to the negative 1/3. So the first thing we might want to do is put that underneath. So we're going to have 1 over 125 to the 1/3. That equals 1 over 5 cubed to the 1/3, which these will reduce to 1, the exponent, and you'll be left with 1 over 5. So our answer is 1/5. Again, I encourage you to pause the video and try problem 2, which is 216 to the negative 4/3. So remember, those are exponents. They're just not showing that high up. So for problem 2, I'm not going to do the whole thing out, but I'll write down the steps. We would have 1 over 216 to the 4/3. And then you can simplify that down, and you end up with 1 over 6 to the 4th. And you could just leave it like that, or you could calculate that 6 to the 4th, 1,296. So 1 over 1,296 is our final answer. Now for example 3, the directions for this say write each expression in exponential form first and then simplify. So we're going to go ahead and take this cube root of 8x to the 6th, y to the 12th, and we're just going to write it in parentheses, the radicand in parentheses, 8x to the 6th, y to the 12th, raised up to the 3rd power. This way it's really easy to see how that index will divide in to each exponent in the radicand and give you the results that you want without, you can take a shortcut with it later, but for now just want you to see how it works. So you would do the power rule, product to power rule. So we have 8 to the 1/3. Then we have x to the 6 times the 1/3, so that would be 6/3, which you could calculate out right away, but I want you to see what's happening. Y to the 12th times 1/3 would be y to the 12 over 3. Then we go ahead and simplify all those exponent fractions. So 8 to the 1/3 gives us 2. X to the 6/3 gives us x squared, and y to the 12/3 gives us y to the 4th. And that would be our final answer, 2x squared y to the 4th. So again, stop the video and try problem 3, and then I'll write the answer down. So what I've written here in red is the answer to problem 3. We would first take the 81x to the 8th, y to the 20th, which is the radicand, raise it to the 4th power. Then we are going to apply our product to power rule. So we have 81 to the 1/4, x to the 8 over 4, y to the 20 over 4, which leaves us with a final answer of 3x squared y to the 5th. Okay, in our next example, we have a 5th root. So this is example 4, 5th root of radicand negative 125, which is okay to have a negative there because we have an odd index. So negative 125, x to the 5th, y to the 10th. So on this one, the first thing we want to do is just pull that negative out, because we know our answer with an odd index is going to be negative. And then we can go ahead and put our 125, x to the 5th, y to the 10th, raised to the 1/5. And then we would have 125 to the 1/5. And x to the 5th to the 1/5, which will give us 5/5. And y to the 10th to the 1/5, which gives us 10/5. Now you can just calculate those in your head. I'm just giving more detail for the video. I can't forget my negative there. So what I can pull out here is going to be the negative I have. I can pull out x, and I can pull out the y squared. That reduces down. And if we think about what's happening with this 125 to the 1/5, so we might want to break that down a little further there. For instance, if we weren't sure right off the bat what the 5th root of 125 is, we can see if we could get 5 factors of 5. Which isn't going to happen, but let's just show how it works when I break it down to primes. 125 is the same as 5 times 25. And then 25 breaks down to 5 times 5. So I have 3 primes, 3 factors of 5. So I could get a 5 cubed, but not a 5 to the 5th. So I really just need to leave it as that. So I want to revert back to the radical format and write 5 in the index and 125. So I can't simplify that any further. I don't want to calculate these out as decimals because I won't get an exact answer all the time, unless they're just calculate out to be a perfect root. So here we have, for our final answer, is negative x y squared times 5th root of 125. So again, try stopping the video, and then I will write out the steps for problem 4. Problem 4 says cube root of radicand 128, a to the 7th, b to the 4th. This one's just a little bit different because you're going to have some leftovers, so see how you do with it, and then I will do it out fully. Okay, so again, using our change of form here, we're just going to do 128 to the 1/3, and then a to the 7/3, and b to the 4/3. So I just took the whole thing like I did before, raised it, that whole radicand to the 3rd power, and then applied my product to power rule. So I didn't write out all those details. And now we have some things to work with. We have 128 to the 3rd power. So if we want to figure out how that breaks down, we're going to have to look at the prime factorization, I think would be a good idea. So off to the side, I'm writing 128. And then I'm just dividing in. I get 2 times 64. 2 is a prime, so I'm going to circle it. 64 breaks down to 8 times 8. And I know from past experience that 8 is a perfect cube, but I'm going to just write it as powers so you can see. So I would have 8 is actually going to break down to 2 times 2 times 2. So I end up with the prime factorization. I have 7 factors of 2. So 128 can be written as 2 to the 7th. So I'm going to do that over on my problem. I'm just like I did before. I'm going to write 128 as 2 to the 7th raised to the third power. And I'm going to just carry down this a to the 7/3, b to the 4/3. So now again, I'm writing out more detail than you would really need to do or probably want to do, but just so you can see how it works. Now this 2 to the 7th to the 1/3 power becomes 2 to the 7/3, a to the 7/3, b to the 4/3. So I'm going to split this apart so that I have, I just break down my exponent to be things that go in evenly without a remainder. So 7/3 could be rewritten, this 2 to the 7/3 could be rewritten as 2 to the 6/3. So I'm just getting a multiple in the top, times 2 to the 1/3. Same for a, that could be a to the 6/3 times a to the 1/3. And by using my exponent laws, I would keep my base, add my exponents. 6/3 plus 1/3 would give me that 7/3 back. So I can just do a double check there. And then b to the 4/3 could be split apart as b to the 3/3 times b to the 1/3. Again, you can just do that in your head if you prefer. And the last line I would do, or second to last, 2 to the 6/3 becomes 2 squared. 2 to the 1/3 just stays as is. A to the 6/3 becomes a squared. A to the 1/3 stays as is. B to the 3/3 becomes just b to the first power, and then I'm left with a b to the 1/3. So I'm going to regroup these. So anything that has a natural number for the exponent, I'm going to write out here. So 2 to the 4th would be 4. And this 2 to the 1/3, a to the 1/3, b to the 1/3, I'm going to deal with those in a minute. A squared just stays as is, and b. Then parentheses, and I am left with 2 times a times b to the 1/3. Those are the things that were the leftovers. So now I want to write those as the cube root again. So I have 4a squared b times cube root of 2ab. Now that's kind of a long way around to do it. You'll probably come up with some shortcuts. You can just think, oh, that index goes in twice. Like if we looked at the, look back here at 2 to the 7/3, for instance, I could say, okay, 3 goes in to 7 twice, and I'm left over with 1. So that power 2 needs to stay under, but the rest pulls out. So we'll do some more examples in the 140 class. 99, that's probably basically all you need to know for now. We'll be working more with business applications, and when you have to solve, we'll go back and look at some more details on that. But don't get too caught up in that for the 99. For the 140, you're going to need these for science applications. There's a lot of exponents involved, scientific notation and things like that. Sorry about that, but you're going to need to do more. So check out part 3 of the video. Thanks for watching. Have a great day.